Welcome everyone on my new course Terraform Getting Started. This course is for beginners and there is no prior knowledge required for Terraform. And once you complete this course, you will able to write your infrastructure as a code in Terraform very easily. It, and I'm using Microsoft Azure for creating and deleting resources. It's only for demo. You can use the concept in all the clouds like AWS, Google, or Alibaba, wherever you want. So let's get it started. Before going to start our course, I would like to understand the problem statement, the requirement, why I want to have infrastructure as a code. So for example, I want to create a small infrastructure for my project where I want only one VM. So I want one virtual machine. I want one storage account. I want one key vault, and that's all. So if I want to create this infrastructure for my small project, I can use Azure portal because it's very easy, handy, and you can fill out all the details. That's totally nice. There's no problem. What if I want to work for an organization and the infrastructure of the organization require 20 VMs, require 50 storage account, require 15 key vault, and the important part is they want to be have same configuration, and every team member can provision VMs of the same configuration in future as well. So if we have such kind of requirement, which will definitely everyone will have in future if they want to use cloud infrastructure. The problem is every team members create resources according to their need, according to their understanding, and many times happen like they create resources with different configuration. So this is the problem statement which we have, that I want to create a VM with specific configurations, same for storage account and same for the key vault, and I want to create those VM multiple times. Multiple resources will be created and there will be no problem in the configuration. All the configuration will be same. So if we want to provision such kind of resource, I don't think Azure portal is the solution. For that, we need to have some kind of code which will run with the automation and provide you the required resources. And the solution of this is Terraform. So this is what problem statement where we can start our course, that I want to resolve this issue, and then let's get started with the modules. So in the modules, we have 7 modules in our course, and we will discuss all the 7 modules one by one in the brief here, and then we will go deep into these modules. So the first module is understanding what is infrastructure as a code, where we will understand the infrastructure code as well as the classic style of maintaining the infrastructure, etc. Second is the deployment of the Terraform. This is the first deployment, how to deploy it. We will understand the creation of the environment, downloading, installing software for this in Terraform. Module third is input output variables, where we will use some variables to create resources and use output of those resources to create create dependent resources. We have the fourth module will be add more resources. So for example, we already have infrastructure as a code for our project, which will create a set of resources. Now I want to add more resources in that code. It's easy. It's not easy right now if you are a beginner and you don't know. It's kind of magic, but that's fine. Once you go ahead with this course one by one, you will understand this. So add more resources, the fourth module. Then fifth is the providers in Terraform. So we have multiple providers in Terraform, and we will see what is the benefits of the provider and how we can implement or add providers into our course, our code, and use it. Sixth one is the functions and looping. This is bit technical but very important if you want to provision your resource and multiple resource of the same configuration. So this functions and looping will help you creating your resource, multiply those resource number of resources without changing your configuration. Seventh is the TF modules. This is one of the most important and the last module of the course. Here we will try to modularize our code to easy to understand, easy to write, so that we have a module. For example, we have module for one VM, and all the team members will use the same module for creating VM, so that the target VM will be created with the same configuration. So module very important. Now let's start our first. What is infrastructure as a code? Let's start with the definition. An infrastructure as a code, also called as IAC, that allow engineers to define their software infrastructure in a code. So if you have your infrastructure and you want to define that infrastructure in a coding language, that coding language is called infrastructure as a code. So if you have like VM, storage account, key vault, and we have the code for the same, this code is called as infrastructure as a code. Going ahead, now the second topic is declarative versus imperative. What is the difference between declarative versus imperative, and what we should use? So I'm hoping that if somebody is working in cloud and they are creating resources, it can be possible they are very good in programming languages like Python, Golang, .NET, etc. And many times it happens like they are not very good in programming language. So what is declarative imperative? In the declarative, we are only know what to do. So declarative is what to do. We are not defining anything else. And imperative means how to do. So this is the main difference between declarative and imperative. Now let's take an example. Having food. So sometimes we prepare food at home and sometimes we order food from outside. So in that case, whenever we prepare a food at home, we have to know what we are going to prepare. So we have all the resources for it, that what is going to be prepared. Then we know the process, how we will prepare, and then we have the hardware to prepare, like utensils, gas, etc. And then once it is prepared, then we have to serve it, and then the final is having it, or we can say eating. So this process is called imperative. And now what is declarative? Declarative means you open your mobile and just say, I want something like samosa. I want samosa, I want sushi, and I want some juice, etc. and order it. You don't have to worry about anything like resource, infrastructure, process, hardware, what is required. I don't have to worry about a whole process. I want to eat samosa, I want to eat sushi, and I want to drink juice. I just order it and then I will get it and have it. So this is the difference between declarative versus imperative. Infrastructure as a code most likely will be part of declarative language. For example, if we are talking about Terraform, because this course is for Terraform, so this Terraform is a declarative language. The Terraform is called HCL, and it is called HashiCorp configuration language. It's called HashiCorp configuration language, and it is a type of declarative language. Moving on, idempotency and consistency. So idempotency and consistency means that whenever we want something, so for example, let's take a previous example. I want to order something from online, and I am ordering, for example, juice. For drinking, I am ordering juice. So if I am order I already ordered a juice, and then I want to order it again, then the application will tell me that you already ordered juice, and that means you already have it. So idempotency means if I run my code multiple times, it will not change anything from the previous state. So it will always return the same state whatever you have. And the consistency means that, for example, there is some changes happen, like somebody has changed any configuration in your infrastructure, and then you want to be consistent. Then consistency means whenever you run your code, the change will be removed and your infrastructure will be consistent state how you want it to be. So it's a consistent, the infrastructure as a code should give you idempotency. That means if you run your code multiple times, it will give you the same result. And consistency means whenever any change happen to your infrastructure and you try to apply your infrastructure as a code on your infrastructure, then you will get the same state what is written in your IAC. So this is idempotency and consistency. What is the benefits of infrastructure? This we already discussed the benefit. The most important benefit is same configuration. Same configuration, because we are provisioning resources using code, and since using code we cannot make error, the code will not make error. That means always if you provision that resource, it will be of the same configuration. Second thing is time management. So you can save so much time, because if you are creating resources manually by clicking here and there, it will take much of the time. But if you use infrastructure as a code, it is very quick. Of course it will take time to provision resources, but you just have to run it, and then that's all. You don't have to wait, you don't have to sit there and click multiple times. Third one is, if you have a big team, then ISC is very important there, because everyone can use the same infrastructure as code for provisioning resources, and the target resource will be of the same configuration. So you can share your code with the team members and they can use this code to provision resources. So these are the three very important benefits. There are so much other benefits. For example, there whenever we are creating resources, so I have seen in Azure, because I worked in Azure, I have prior knowledge of it. So I have seen in clouds, whenever they release some properties, it can be possible those properties are not shown on GUI side, and those properties you can have in your infrastructure as a code. So for example, let's take an example of Azure. So Azure usually provide infrastructure ARM templates for creating resources, as well as ARM APIs for creating resources. So whenever Azure releasing any new feature, sometimes that feature is present in the GUI as a preview, and sometimes those features are not present in GUI, and then you have to provision those resources from some kind of code. For example, from creating resources directly from Azure portal, you have to log in from your ID. But if you want to create resources in Azure without using your ID, or using some kind of automation, like some pipeline, some CI/CD pipeline, some automation account you want to provision using that, in that case you have to log in. You can use manage identity for creating resources, you can use service principal for creating resources, and that feature is not present in GUI. So that's one more things, like some features not present in GUI. So these are the basic benefits which I can see of infrastructure as a code. There are some others, we can discuss it later. So this is the summary of this whole module 1, what we understand that what is the definition of infrastructure as code, what is the difference between declarative versus imperative, what is idempotency, consistency. Idempotency, I told you, same state. If we run our code multiple times, you will get the same state. Consistency is maintaining the same state. Benefits we already discussed. We can share the code with the team members, we can provision resources very efficiently, and the configuration will be same for all resources. Summary of this course is done, so let's move into the next module. So next module is deployment of first infrastructure as a code, or I can say first Terraform project. We will deploy it in this module. So what is Terraform? Terraform, I told you, it's a HashiCorp configuration language. It's a declarative language. And what is declarative language? Under declarative, we know what to do, and it is a kind of infrastructure as a code language. Now let's discuss the demo. So in the demo we will understand what are the software required to install, and for us to make creating our labs or replicating our labs in your infrastructure. I will share all those things here. So search for Terraform install, and we have to click over here, Terraform install. It's showing for AWS. We don't have to go to AWS, we just click on Terraform, and here you can see the install button. And if you install, you can install for Mac OS and other OS as well. I am using Windows, so I can install it. Just click on download. It will download this file, and what you have to do is just to go, let's get it downloaded first. It's downloaded, and let me open it. So it's downloaded here. Let me try to extract everything here, and when we extract, it's extracted, and this is the file. So this file, this binary file, you have to keep it in your laptop or computer, and put this file location in your environment variables. So for example, let me give you an example here. Let me close it and open my environment variables. So environment variable here, and if I go here, and you can see in my path, I have put my binary file in my binaries, my bin, and I'm keeping my binaries over here. So Terraform binary is place I have in the C drive, my bin, and the C drive, my bin, I have keep my Terraform file here. So that whenever I run my commands, my software will understand where it will try to find this binary. This is the first thing. Second thing, I'm using VS Code, Visual Studio Code. So you can also download Visual Studio Code very easily. VS Code download, it's easy to download and install it. So click on here. I will share this link in description, and you can download for Mac, for Linux. I am using Windows, so I downloaded this one and install it. What else you want to download? Yes, you want to download AGCLI. So if I go for Google and make it like download, I need to download for Windows, and here you can download it. And once it is download, you also have to keep it somewhere in the path, in the environment variable. You have to keep it somewhere, just like I put my all the binaries in C my binaries. So you can also use that same kind of things in your infrastructure, in your laptop. And once it is done, we are ready to do. So let me start my VS Code. As you can see, I have already opened, I am already having ready with my module codes here. So it's a module 2 code, module 3, module 4, module 5, module 6, but we are not going to do the same. I will start from the scratch for you guys so that you can understand. So let me try to open. Okay, in the file I will try to open a folder, and let me go to document, and here I will create one folder, Terraform demo, select folder, and then start. In this, let me try to create one folder here for module 2, and inside module 2 I will create 3 files, or I can say main.tf file only, and here I can write my code. So installation is done. Get familiar with Terraform CLI. Let me go here and show you some Terraform terminal. I want to need to have a terminal, and let's see some Terraform commands. So first of all, let's see which version we are using in the Terraform. We are using 1.5.4. This is the current version. And then if I write Terraform -help, then I will get all these commands like init to initialize your project. Then we have validate to validate our code, whatever we have written, it will validate that. Then we have plan, just to uh, check what we are going to provision. It will create a plan and check the changes. If you have provisioned some resources and now you made some change in your code, it will check and let you know those changes. Apply means you are going to provision, or you are going to do something now on this. Apply means you are going to provision resources, or you are going to delete some resources. It's up to you if you have written in your code. And destroy means whatever you have provisioned with your Terraform, it is going to destroy all those resources. We have other commands as well if you want to see. So the console fmt, I use this fmt a lot to make my code formatted, properly formatted, able to easy to understand, easy to write. We have some other commands, Terraform output, providers, etc, etc. So you can go through these if you want, but for basic understanding you don't have to use it all. You just have to work on these main commands, which is init, validate, plan, apply, and destroy. Terraform objects. So TF objects. So what is TF objects? So I have a sample here to create some resources, and here if you see in the right hand side, I am trying to create a resource group here. So I am trying to create a resource group here, and let's understand what are these objects. So first of all, in the first block, I'm defining the configuration we are going to use for Terraform. So I have written a block called Terraform, and what are the providers I'm going to use? I'm going to use Azure RM, and the version of the Azure RM should be equals to 3.0.0. This version can be greater than, we can write like 3.0.0, so we can use greater than 3.0.0, or we can write like less than 3.0.0 if our infrastructure is dependent on this version. But since I have written all my code for 3.0.0, so I am making it like its exact 3.0.0 version should be used for Azure RM. Then we have this providers block here, so I am using Azure provider. If I want to add some more features, but I don't want, I'm going to use the default configuration for Azure RM, so I don't have to define anything here. Then we are using this next block, is called resources. So in the resource, I'm trying to provision resource of type Azure RM resource group, and the resource group name, and the resource name is RG. And then what is the name of this resource group? I want to create a resource group with name RG test1. And what is the location? I want to create it in the West Europe. So these are the basic objects which we are use when we are going to create a resource using Terraform. Moving to next topic, the block syntax. This is, I already discussed here, that these are the blocks which we are using. This is the first block for Terraform definition, what we are going to use in the Terraform. Then we have how many providers we are using. This is a provider block, and then we have resource block as well. Now let's try to write our code and then run it. So moving on to our demo. In here, first of all, we have to write, let me make a zoom. Okay, I think it's zooming enough. Without wasting time, I will take an example from the previous one, and the same which we discussed. I'm using Terraform, and providers I'm using Azure RM. I have defined my versions here, then I have defined the provider block here, and then I have defined my resource block here. We already know some commands, so before running commands, what we need to do is we need to log in. So I try to log into my Azure AGCLI. So I have to write AG login. It will prompt me to log in here. I will click on my email ID, and it said that if you are logged in, you can close this browser. I closed it, and you can see I already logged in. So since I logged in here, let me try to go inside, clean. Then I am going inside to my folder where I have my main.tf file. So going for 02, and first command we will run is terraform init. So once I will run this terraform init from my folder where I have my terraform files, it will say your terraform has been successfully initialized. The second command I normally run, but it is not required that you have to run it, terraform fmt. It will format your code. So for example, you have this equal sign here, and then you have your equal sign here. It's not properly formatted. You run this command and it will be properly formatted. Good. Now what next is, once you initialize your code, then you have to initialize validate the code is correct or not. So I'm running my command validate missing required providers. This configuration required providers register Azure RM, but that provider isn't available. You may be able to install it automatically by running Terraform init. So somehow we don't have this provider installed. So what we are going to do again is to run Terraform init, and it will try to initialize my code, and it will try to download those providers. I think earlier I haven't saved my file, this main.tf file. I haven't saved it, and that's why I ran this Terraform init, and it didn't downloaded these files. And since I have downloaded all the providers, now if I run Terraform validate, and my configuration is valid. Next is Terraform plan. So it will tell me that what resource it is going to create. Let me. So here you can see Terraform uses the selected provider to generate the following execution plan. Required action are indicated with the following symbols. It's required to create some resources, and what resources it's going to create? This one. So in the last, you can see the summary. Plan 1 to add, that means one resource is going to be added, 0 to change, and 0 to destroy. Let's hit Terraform apply. Now I'm going to create these resources in Azure. In the same time, let me log into Azure as well. So just to confirm, portal.azure.com. I need to provide my credentials. Okay, I'm logged in. I go to resource group, and let me try to see. It is saying these resources are going to be created. Are you sure? Yes, of course I'm sure. Azure Army resource RG creating, and after some time, in the 1 second, it's saying that it is created, apply completed, resources 1 added, and 0 change, 0 destroyed. Let's check is it true or not. So we are here in Azure portal, and let me refresh it. It will always take some time, like some seconds, to show it here. So now you can see resource group has been created as expected. I want to create it in the West Europe because I am here in Europe, so it's very near location for me, and the resources created. Now another thing is I want to destroy my resources. So Terraform destroy. So what is going to be done here? Under this command, it will try to destroy all the resources which is part of my Terraform code. But before going there, let's discuss something interesting. So have you seen I have written only one code here in the main.tf, and then we have created, whenever we are running, we have now these new files here. So this is the providers which are getting downloaded. This is .terraform log. So this is a log which is getting created whenever we are trying to create resources on the state file. We will discuss the state file in detail in future, but let's discuss a little bit here. And this state file has been created. So here we have some resources, and here we have all the properties like ID of the resource, which location is getting created, name, and some uh, private encrypted string here, which Terraform understand that okay, this resource is part of their Terraform state. And now over here I am just going to destroy Terraform destroy. So here you can see it is trying to destroy it, and after some time it has destroyed. Destruction completed in 16 seconds, and it has destroyed one resource. Let's confirm. Let's go to the portal. We already have this resource. Let me click here, and you can see resource not found. That means resource is already destroyed, and if I refresh it, it will be removed. So we have destroyed this resource. Let's get back to our presentation. We understand Terraform workflow by running those commands like uh, Terraform plan, first Terraform init, then Terraform validate, then Terraform plan, and then Terraform apply, and the last was Terraform destroy. So we already discussed all the Terraform workflow over there, and I already showed you the deploy part, how to deploy resources, and then the summary of this module. In this module we have learned what is Terraform. We have seen what are the software installed, what are the software needed to run our Terraform. For example, Terraform binary, we require Visual Studio Code to write our code. We require Azure CLI to log in into the Azure and use that login for Terraform. And then we familiarize with some Terraform commands like init, validate, plan, apply, and destroy. These are the main commands for Terraform, and some other commands like fmt I showed you. Then we understand about the Terraform objects like Terraform block and some other like resources, providers. Then we learn the block syntax, that we are writing all the code in small blocks. For example, we are writing resource group block over there in a resource block. Then we understand, we already gone through code dry run. We have read all the code. Then we understand the workflow of the code, that what needs to be run first, which is always Terraform initialize, which is Terraform init. And then we can validate, and then we plan, then we will apply. And then I try to deploy resource, which is I try to create resource group in Azure, and we are successfully deployed it, and also we have successfully destroyed it. So we have finished about this module. Let's move on to another module. Let's start our third module, input output variables. So let's understand what is variables and how we are using this input and output variables in Terraform template. So for example, if we have some Terraform template here, Terraform template means some TF files, .tf files. We have written our uh, machines, virtual machines code, storage account code, some other infrastructure code, and now we want to parameterize it, like provide some variables. So here we have input variables. So we are using this input variables. We provide this input variables over here uh, to our code files, and those Terraform files will produce some output output parameters or output variables. And then by using input variables, we can create resources with the required parameters, and with using this output variables we can use the properties of the resources which are created by our IAC. Let's get deeper into it a little bit. So understanding input variables. So in the right hand side, if you see this screenshot here, how we define input variables. So we define it as a variable with the name of the variable and the type. So which type? Like right now you can see it is a string type. I'm giving resource group name to my infrastructure as a code, and that's why I'm defining it as a string type. And what is the description? You can describe it. Resource, I'm describing it as a simple like resource group name. Default name you can give, default value I'm giving as default RG. And another variable, for an example, I'm using location. You can define location here, you can define a string here, you can describe it. You can use default as West Europe. And one more thing which is important here, you can define the location from as a type of string as well. So if you want to use multiple locations for creating multiple resources, you can define one location, two location with the comma in the middle, and you can define like West Europe, East Europe, and North Europe, Switzerland, East US, etc. So it depends, but for us we are creating resource group. So for resource group we are creating only one, and we require only one value for the location. Now next step is using let's give you a demo how to use it. So let me open my Visual Studio Code. Let me create a quickly new folder for 03, and I will just copy this main which we have already discussed, and I downloaded it earlier in module 2. And we will start from here. We will not start from scratch, we will start from here where we already have this Terraform block where we have defined the Terraform configuration. Then we have this Azure RM block, and then we have this resource group block. Now here what we are going to do, we need to define some variables. We can define it in the same file, but I always prefer to have a different file to define the input variables. Let me create one file here. I'm giving this name as a variable.tf, and let me open it into the right side. I always open my files parallelly. It's easy to write my code in this way. So I'm just parameterizing this value, these two values. So for parameter, what I'm going to do here is I'm defining variable, and the variable name is rg name. And then what type of variable is it? So here you can see you can define bool, list, map, number, even an object as well, tuple. So there are so many things we can define here, but for rg name it's a simple string, so I'm making it as a string type. Description, if I want to give some description, what is it? This is resource group name. Okay, and now if I want to give as a default value, so default value is like if I will not provide an input parameter from while I'm running or from different file parameter files, if I'm not able to provide it, then automatically it will take this value. So I am putting as a default -rg. So if I will not provide any if I will not provide this value for resource group, it will automatically take default RG as a variable value. Next variable I'm going to define is location. So if I'm defining this location, let's put as a type equals to, it is also a string type, straightforward. Description, we can make it location of resource group. We want to give it as a default value. Yes, we can give. There's no problem in that. So I'm taking it as a West Europe. Save it. And now how I will use these right hand variables into my code. So I will remove this name from my resource group resource, and I will use var and then dot rg name, and for location I will use dot location, and that's all. So this is how I have provide some input parameter for my resource group to be created. Okay, and now if I want to run this code, I just go to terminal. I will run Terraform. I hope you remember which command I should run first. It's Terraform init, of course. And you see Terraform initialization is an empty directory. Why? Because I am not in the correct directory. Right now I am in the Terraform demo directory, which is the parent directory of my module directory. So I have to go inside my directory where I have all my Terraform files present. It's a good learning. So I'm here now, and now Terraform init. So it is now initializing it. So here you see initializing the backend. Just to give you one brief idea, initializing the backend. In this course, we are taking backend as our local file system. So the backend means where your target Terraform state file will be created. I will create a separate video for this backend because it is little bit deeper or more technical compared to the getting started course. So I have separated it out. So I will create another video for it, so where you can see or you can learn how to use different backends like Azure storage account, AWS storage account, S3 bucket, or any other storage account, or we can use Terraform cloud as well for our web backend. But that's for another video. For this video, it's a getting started video, so we are taking backend as our local file system. So for example, this terraform.state file in the second module which we have done, the tf state file is created inside the same folder where we are doing our deploying our resources. So yeah, we have initialized our code and Terraform has been successfully initialized. I hope you guys remember that what is the next command we need to run now. So Terraform, yes please. Okay, so Terraform validate. It will validate the whole code. Okay, success, the configuration is valid, very good. Next is Terraform plan. It will let us know that are we going to, what are the resources we are going to create, or if there are any changes in the resource. So it will let us know the output, like what is going to be happen from our IAC. Okay, so it is going to create a resource group and the name is here. One resource is going to be added, nothing is going to be destroyed. Let's deploy. Terraform apply. And now since it is applying, you can see in the left side the lock has been created. So since it is the lock has been created, so nobody else can do anything on this TF state right now, because my process has taken lock on it, and since my process is taking lock on it, so nobody else can update it. This brings us the consistency of the infrastructure. So if I'm working on some TF state file, nobody else could do anything on the TF state file, otherwise it will create a problem to maintain the infrastructure. So I'm saying yes. So once it will deploy my resource, this lock will automatically get removed, and then anyone else from the team can use this TF state file. So now you can see I have deployed my resources and that lock is also gone. And in the portal, if I want to check, just a second, let me open it, and portal.azure.com, resource group, and you can see this resource group has been created. Good. Let me go to the presentation once again. Okay, demo completed. Next one is understanding the output variables. We understand the input variables, we know how to define input variables and how to use those input variables into our IAC. Now comes to the output variables. Exactly what exactly this output variable is. Output variable is whenever we are going to create any resource, that resource will have some properties in it. For example, for let's take example of resource group. So whenever we are going to create a resource group, then resource group will have some property intact with it. In what are those property? For example, the name of the resource group, where the resource group has created, what are the resource ID of it, so etc. Like these kind of different properties. In storage account they have different properties like public access is enabled or not, blob access is enabled or not, key access is enabled or not. Those kind of different properties are there in storage account. So all the resources have their properties intact. Now if I want to access those properties, once I have created the resource and now resource is there in the cloud, and I want to read those property in my code so that I can create other resources on behalf of those property, I use output variables. An output variable is very easy to define. Output variable is simple: output, then output variable name and the value. Here you can see this is output, and the block name is output. Earlier it was resource for creation, and for variable it was variable, and now for output variable it is output, then the output variable name, and here what is the value I want to return as a output variable. So here you can see I am returning this is the provider, which is Azure IAM resource group. This is the resource provider, and what is the resource name? Resource name is resource group dot id. Remember, this is not the resource group name, it is the resource name in the code, in the block which we have defined. What is the resource name of that block? So it is not a resource group name, it is the resource which I have created. I will explain you when I will give demo of it. So this is the resource which I have created, and this is the ID which I am returning as a output value. So next step is demo. Of course we are going to give a demo for it. Let's go here. Okay, so variable is done. Let me create one more file here, output.tf. Let's define output variable here. So as I already showed you, it should start from output, then the output variable name. So let's take it as a rg resource id. We will give it rc resource id, and what is the value of it? If I go equals, and now I will define which resource ID I want. What resource ID I want? I want resource ID of my resource group which is created under this block. So in this block, first I need to use this provider. So Azure RM resource group, this is a resource provider. Then what is the resource name here? It's not a resource group name, it's a resource name. So here it is rg dot, and then what value I'm going to give it back. So now here you can see we can have id, we can have location, name, and tag. So that means the resource group can give you these four properties as a output. So let me give the id first. So I am returning the id. Now I will save it, and once I will save it and I will run Terraform plan, let's see what output we are going to get as a Terraform plan. Okay, so now here you see I haven't destroyed anything, I just created this default rg resource group. So in this Terraform plan I have added this output variable. Here you can see it is not going to create any resource, we are not seeing any resource, but I am getting this resource id as the output. So what is the resource id? Resource id of the resource group, which is subscription id, resource group, the resource group name. This is the id which we are getting as a return in the output, and we can use this resource id output variable to create other resources in future. Let's go to the presentation again. Okay, we have seen this output variable demo. Now validate the configuration. This validation of the configuration I already shown you, which is I hope you remember the command for validation. It is Terraform. Remember command validate. Whenever we run this command, it will validate the code and check it if there is any syntax error there, or is there any dependency graph error there. If there is the error, we will get it here and we will correct it. So yeah, that's already discussed. Now deploy the configuration. Let me try to deploy it again and see what will be the output here. Terraform apply, and you see here no resource has been created, changed, or destroyed, but we get this output here. What is the output? The resource id which we have defined. So we are able to create resource group, then later on with the help of the input parameters here, and then we are able to give the output also with the help of output variables. Let's go back to presentation and the summary. So we have completed this module where we have learned input output variables, that how to define input variables, what is the use of input variables, same time what is the how to define output variables and what is the use of it, and how we can use output variables in creating other resources. We can see those in next module which is coming up right after that. Add more resources. So here you can see we are going to add more resources in our Terraform file. Of course, we are not going to create Terraform. We are not going to use Terraform for one resource. We are going to use Terraform when we have multiple resources and these resources are dependent on each other. So we are going to do that. In the right side, you can see the first block is trying to create a resource group which we already demoed it and we are able to use it, but perfectly fine, no problem in that. And now we are going to create one virtual network and then one storage account in my code. And once we will create these resources, we will use output variables, we will use input variables, etc., everything there, and make it more like good more like good looking Terraform files or Terraform infrastructure as a code. So let's go for documentation. It's a documentation time. There's no shame in reading documentation. Documentation reading is totally fine. I always follow document religiously. Terraform, go directly to the Terraform. Before going to Google, I always search my queries in the documentation. If I'm not able to find easily, then I will go and search in the Google. So let's go for Terraform Azure documentation. I'm searching for documentation only for Azure, but if you want, you can go for other clouds as well. So before that, let me go and click on providers. So here you can see AWS, Azure, Google Cloud, Alibaba Cloud, Kubernetes. We have so many providers here, if you can see. And there are some packages which is provided by individual people as well, just like in GitHub people used to have their own code. So those are also provided here, but mainly providers are AWS, Azure, Google, Alibaba, Oracle, Kubernetes, etc. So now we want Azure documentation, and in Azure documentation I open and click on the documentation, and here you can start understanding things. So if I click on the example uses here, this is similar architecture. We have this Terraform block where we have defined our provider, which version I'm going to use. Here we have provider, which is Azure RM, and the feature I have skipped it. And then we have this resource, what resource I'm going to create, and other resources as well. So this is the documentation, and it's easy to understand, easy to read, no problem. And if you want to search for some specific resource, in the left side in the filter you can write like storage account. So in the storage account you can see in the storage module we have these resources, and the resources we have this storage account, and this is how the code will be written. So I'm just going to copy this, and let's paste it into the next when we will write our code. So demo adding virtual network, and then demo adding storage account. I will show both of them in the single demo. So here, if I see, we have our code ready for storage account, resource group. Now I want to add here virtual network. So I will define resource. You can search your provider resource here as well. So here I write Azure RM underscore. If I write network, then you can see I have this so many things here: network watcher, security, etc., etc. So if you want to create a network, virtual network, so what resources required to be here? We need to have a virtual network resource. So let's search for virtual underscore network. Here you can see the first resource. I want to create a virtual network, so this is the first resource provider, and now we need to give it as a name. So I am giving it a simple name called VNet. I am creating a VNet, and now I have to provide some other values here, for example name. So VNet name will be VNet 01, or yeah, that's fine, VNet 01. Which location I want to use? So if I want, I can define the location like West Europe here. West Europe, that's totally fine. But I want this VNet to be created in resource group this one. So what I'm going to do, I'm going to use the same resource location of my resource group. So I will not define it like this. I will define it like Azure RM resource group, Azure RM underscore resource. So it is already there. Azure RM resource group dot rg, then dot location. So I am using the location of my resource group for creating the VNet. And now in the next one, I have to provide the resource group name here. So if I write resource group name, that is mandatory parameter which I need to provide, and I will use the same scenario earlier. I will just use the previous resource properties, and here I have to provide the name. And now last but not least, we have to give the CIDR range, IP CIDR range. So for that we have a property called address space, and here you see it is a type of slice of a string, not slice, you can say in Golang it's called slice of a string. How to say it here, it's a group of a string, so we can have multiple CIDR range here. So I'm just using one, it's 10.10.0.0 slash 16, and if you want you can define more here like comma something like, I just copy this one and define this one and put it as 11, but I don't want to do it. I just want to create a simple VNet, because this class is not to understand virtual network, this class is to understand the Terraform. Okay, I have saved it now, and I want to create storage account as well. So resource, which resource I want, Azure RM underscore something storage. So you can see the first resource is storage account, and the name of this one is storage account. Simple. Now I have to define the name of this storage account. Here the storage account name should be unique, it should not be taken by anybody else. So what I'm going to do, I will just write stag, then write some random value here and write some here, some numbers here, so that it should be random or it should be unique in the Azure world. So it should, the storage account with the same name cannot be created twice, even if it is a different subscription. Okay, so name is done. Now what else is required? Location. We want location for my storage account. I will use the same location like my resource group, Azure rm resource group.rg.location, and in which resource group it is going to be created. So I will use the same like earlier. Okay, and what else I can define? I can define which account tier should use. So account tier, I should give it as standard, and the replication of this account replication type, I want it as LRS, local redundant. Now how you are going to get this properties? You are getting this properties when I am hitting this as well. Some property you can get it, but you will not get proper definition of it. For that, documentation is always good place to learn. So if I click on documentation of storage account, here you can see the name, it is a required field, and specify the name of the storage account. Resource group, it is a required field. Location is a required field. Now account kind, it's optional. Define the kind of the account, and you can define it like blob storage, etc, etc. If you are not giving it any value, it will automatically create it as a storage v2. Same, you can give this account here is a required field, we need to define it as a standard or premium. If I go down, there are other properties. For example, account replication type, it is also required. I want it LRS, GRS. LRS is local redundant, GRS zone redundant. So we can define these. There are other things as well which are optional. If you want, you can use it. For those, we require to have a separate video on storage account to understand all these properties for a storage account. I need to show you some important thing here. The important thing is there are some properties in the resource which you should not change until unless you want to create a new resource. For example, if you are going to create a resource in one region, so for example, we are creating resource in one region. We will discuss it and when I will demo it. So for example, now I have added VNet, I have added storage account, and I will try to deploy my resources. So let me try to deploy Terraform plan. Okay, so now we have seen some problem here that expected account tier to be one of the standard or premium and got a standard. So now I have done small mistake here. I should have run Terraform validate first, and this will give me that I have written standard in running, and it should S should be in the capital of the standard. So I will make it as a standard here. Okay, and now my validation should be running fine. Okay, success. Clear the screen. Terraform plan. Now we are going to add two resources, 0 to change, 0 to destroy. Let me make it up. So here you can see so many properties of the storage account which you will get to know when it is deployed. For example, primary DFS endpoint, file endpoint, location, primary location, secondary location, etc., etc. So many properties which you will get to know once it is deployed, and you get to know about the storage account it is going to be created, and there is a virtual network which is also going to be created. Let me try to deploy it. Terraform apply. Okay, so you see it has deployed two resources. We know one is the VNet, another one is the storage count. No change, no destroyed. And let's go and check it in the Azure portal. So we are here. Let me refresh it. So this network watcher RG is the by default created by the Azure, because we have created virtual network. We don't have to worry about it. Our resource group is default RG. We will go inside this, and you can see there is one resource which is virtual network has been created. If I click on it, you can see this is 10.10.0.0/6 CIDR range, and another resource is the storage account, and the location is same, West Europe. So yeah, we are able to create these resources. Now going back to my code, what I was discussing earlier is that if we want to change something here, so for example, I want to change the location of my storage account. For example, right now it's West Europe. I want to create this storage account in North Europe. What will happen? And this is very important, and please listen it carefully. Sometimes if we are going to update some properties of any resource, it can be possible the resource will get deleted because of the property change. And once it is get deleted, then it will get recreated again with the correct properties which you mentioned here. And sometimes it happened that you don't want to get the resource deleted because of the some property change. So now I'm trying to update the location, and then let me try to run my Terraform plan here, and let me make it big. Okay, so now here you see there is one resource which is going to be added, and there is one resource which is going to be destroyed. Now which resource I am going to destroy? You see this minus sign? This minus sign is saying that this all things will be removed. And where it is going to be removed, you can see here. Azure RM storage account must be replaced. And why it is must be replaced? Because here you see I am changing the location, and which causes it force replacement. Now how you will get to know that which property we can change without replacement and which property we can not change without replacement, that you can understand and learn from the Terraform documentation very easily. Now let me go to the resource. So in the resource, it is saying specifies the supported Azure location where the resource exists, changing this force a resource to be recreated. It will recreate resource to be created, new resource to be created means it will delete the resource and create a new resource. Same for here. And if you see here, if we change the account kind, it will not recreate your resource. But if you change the tier, it will recreate your resource. So you can learn this for whatever cloud technology you are working on. You should always be precautious about it, that whenever you are updating any properties using infrastructure as code, always remember that are you seriously want to uh, recreate the resource. If not, then check the documentation properly check the documentation. And once you check the documentation properly, that the property you are changing, it should not delete the resource and then recreate it. You need to check it and then try to deploy it. So now I don't want my restores account to be created in some other resource, some other location. I'm just changing it to my old location, and just let me run my plan again. And now it will say nothing to change. So no changes are required in my infrastructure. Everything is up to date. Let's go back to our presentation. So we have demoed on both of it, working with the TF state file. This is one of the good topic we need to understand. TF state file. I try to introduce you with the TF state file, but not thoroughly. So now we are going to check TF state file which is getting created here. Let me close this now because it's more like theory, but it's good to understand here. So whenever we are deploying our resources, this TF state file is always getting created. And in the TF state file, this state file will keep the infrastructure which we are creating, the all the properties and everything related to that resources which are getting created. It will keep all those properties here. So if I click on this one, you can see this is the metadata about this is the metadata which is related to my Terraform. And then here we have some other outputs which we are giving. You know that we are printing some output value for my resource group. And then here are the resources. So there is one block here, this is containing everything. Then we have one block for output, and then we have one block for resources, and we don't have any other block right now. Later on we will have multiple blocks here, but we don't. So output, we already learned that this output is only I'm printing the resource ID of my resource group. So you see, whenever I'm saying print the output of resource group ID, this value is getting printed here on the console. Now if I open this resource group, now in the resource group it is managed by Terraform, and this is the type which is Azure RM resource group. And what is it inside this? We can see we have defined all the properties related to my resource group here. Now another resource, this is the first resource. So let me close this first resource. Now another resource is Azure RM storage account type. And here we have defined all the properties, and you know that these properties we can use as a output variable. This all properties we can use as a output variable. This is the ID we can use. If we want to define a managed identity for our storage account, we can use it. Some other properties like this primary blob endpoint, secondary blob endpoint, etc. So it's use list. So yeah, we can close this another resource as well. And there will be one more resource which is a virtual network, and here we have properties of the virtual network. So Terraform state file is containing the properties of all the resources which are created by our Terraform. Okay, there is one more trick here, that it can be possible that some resources you can create by yourself in the cloud, those resources which are created by you, by yourself, going to the Azure portal, not by the Terraform, the properties of those resources will not be here, even if those resources are related to your resource. For example, uh, you are going to create storage account using Terraform. You created a storage account, but manually you went on Azure portal, and there you have created some containers under that storage account. That container property will not be here in the Terraform. You have to define everything in the Terraform. That's why it is a saying, if you want to manage your infrastructure from Terraform, always use Terraform. Always, for all the updates and everything, always use Terraform. Otherwise it will be a mess. So this is the TF state file where we are keeping all the information, what are the resources are getting created, what are the properties of the resources, etc. here. And now if I run, for example, I run destroy. Let's see. If I run destroy command, it will try to destroy. Okay, just a second. 03, and then run Terraform destroy. It will try to destroy all the resources which I have created. Okay, so all the resources, all the three resources had been destroyed, and now we will analyze what is there in the TF state file. So if I go open TF state file, you can see only metadata related to the Terraform is there, and except this there is nothing present here. Everything is gone because we are not maintaining any resource group, we are not maintaining any virtual network, and we are not maintaining any storage account. Let's get back to the presentation again. State data scenario. So what is a state data scenarios? So in the state data scenarios means that you have your Terraform code. So it is TF code. Then you have your Terraform state file. So dot TF state file. And then in the last you have your Azure cloud. Azure cloud or AWS cloud or any other cloud. So now if you are creating, the first scenario is that when you are creating your resources using Terraform. So for example, you are creating, you have written your code for resource group here, and then you are trying to deploy it. Then this resource group will also present here, and then this resource group will also present here. So this will lead to create this resource group in the TF state and also in the cloud. Now take an example that we have one storage account here. For example, one storage account created in the cloud, but we don't have code here, and then we don't have in the TF state. If that is the scenario, then we cannot manage this resource from the Terraform state file. Now there is one more scenario, third scenario. For example, we are having, I should write this third over here. So we have this third scenario here, that we have one resource which is Terraform. For example, storage account 2 we have written in the Terraform. We have this Terraform as storage account 2 in our TF state, but somebody has deleted it manually on the cloud. If that is the case, then we cannot recreate the same resource again in the cloud, because whenever we try to deploy our code will check the state file, and when it checks the state file, it is saying this is already present, then it will not deploy it. And for resolving this and resolving this second scenario, first is the ideal scenario, that is totally correct. Second one is when your resource is present in the cloud but not in the code. And the third, when resource is present in the code and the Terraform state but not present in the cloud, then we cannot maintain or make those we cannot create those resources using Terraform. We have to do some extra steps. And that's why for scenario like 2, this is scenario, my English is not so good, so writing is also not so good. Scenario 2, for this we have something called Terraform import. So in the Terraform import, what we are going to do, I will not show the demo of Terraform right now here because this is getting started class, and if we go deeper into these kind of situations, it will create a problem. But I will just give you one small theoretical example here. So in the Terraform import, what we are going to do, we will define our infrastructure for the same code, same resource in the code, and then in the state file we will run this tf import, and this tf import will go and check the target resource as well as the code and try to bring all the properties over here. And once all properties here, then we are now managing this resource using Terraform, and then we are changing anything in the code and deploy it, it will affect, and effect will be applied on the target. About the second one here in the scenario 3, so in the scenario 3, what we are going to do here, we have something called tf state remove. So we will use this command tf state remove. It will remove the resource. Here we have to give the resource. Here we have to give resource ID of the Terraform ID of the resource. And once we will provide this information, it will remove the resource from the Terraform state file. And then in the next time when we will deploy it again, it will try to create the resource, and then it will be a synchronized resource and it will be managed by the Terraform. So these are the some scenarios. These are typical scenarios which we can face in future whenever we are working on the Terraform. That's why if you are using Terraform, try to use only Terraform to update, delete, create your resources in the cloud. Deploy updated configuration. So I already showed it to you. Updated configuration I already deployed, and I showed you the state files, that what are the changes happening there, etc., and the summary. So in this module we have learned that how to use the documentation of Terraform. It is very useful and there is no shame in using documentation. It's totally fine. And how to use more resources, like I showed you virtual network storage account. We have discussed about the TF state file, that how the properties are bringing to the TF state file and what are the properties you can read from there. And we have learned about the outputs which are running from the TF state file, and the state data scenarios where we are maintaining some resources from TF state file. There are some resources which are directly created on the cloud, but those resources are not present on the TF state file, etc. And in the last, we have already I already showed you how to deploy, and after deploying also we have read the TF state file. So let's go to the next module, which is providers. Okay, so let's start our fifth module, providers in Terraform. Till now you have seen we are using one provider, which is Azure RM, which is dedicated for Azure resources. There are so many other providers present in Terraform which we can use for provisioning resources and some other stuff. Since it is getting started, so we are going to dig little bit deeper, not much, to see what are the providers present and what we can do with those providers. So we will see the providers block, how it looks like. So let me show you in the demo, and then we can use the demo to extend and use providers, some random providers from Terraform. So let me just open my demo VS Code. Where is it? Where is it? Okay. So we are here. I have done small formatting here, that earlier I have created everything in module 3. So I have made some small changes in the main.tf. We are having this resources which we have created in the last and demo. Resource group we are creating, vnet we are creating, and storage account we are creating. And in the terraform.tf we are describing about which version I want. And here you can see till now we are using only Azure RM provider, nothing else. And in the variables we are using resource group as a variable and the location. So now let's go and try to use a new provider. First we will go how many providers are there in Terraform. So you can go to registry.terraform.io, browse providers, and here you can see these are the providers provided by the Terraform. Some are provided by the HashiCorp, some are open source provider by some independent people, independent organizations. So you can see there are so many providers. They are provided for Commvault, Clumio, etc. So now we are going to search for one random provider. I'm trying to see this random package, and we will use this provider into our project. So what this random is doing is, this random is trying to give you a random string by defining some parameters. So let's try to see how we can use it. So in the documentation, if I go, you can see the random providers allow you to randomness within Terraform configuration. This is a logical provider, which means that is works entirely within the Terraform logic and doesn't interact with any other services. If you want to go through the theory more, you can go there, and they have given some example as well, that how it can be used. So here you can see we can have this random underscore id, and then we are using it as a hex, and here we have random id as a server, etc. And now how to use it, we can go here and we can go for random provider. We can go random id, random integer, passwords, or file string. We are going for the random string. We want to generate a random string out of it, and we want to use this block. And here you see in the we required length, that what is the length of it. Then we have the keepers map of the string. We want lower only, we want lower should be there. We want minimum how many lower character will be there. We want how many minimum numbers will be there. So we have these properties here. So now let's use this provider block. So for provider example user, you can click here, you can directly go to the example how to import it. We can see this is the import. If you want to import, we can import also, but we don't want to do it. We are just going with the here. So first of all, you see I click on the use provider, it has given me this output. Like first I have to define this random provider into our Terraform block. So this is I showed you earlier that Terraform block, that's why I made this different now in the different file. So we have a different file Terraform block, and here we already define our Azure RM provider, and now we have to define our random provider as well, just like this. Random equals to the source, I want this one, and the version I want this one, exit this one version I want, and okay. And then here in the providers I will just say random, and the feature will be, I'm taking no special feature, so it will be empty. So this is how I have defined my provider, that this is what I'm going to use in our code. And inside this main I will write resource, and here I will try to write random, and we can see here we have this string. And you see have you seen that this is HashiCorp provided package. And there are some random there are some open source packages also present which you can use, but recommendation is always try to use which is provided by the HashiCorp, because these are authenticated packages and these are frequently updated, and there will be less chance we will find any vulnerabilities. So I will just write it as a random string, and inside this we can say what are the outputs. So I want lower characters, so lower, it's true, it's lower, it's a boolean, lower should be true, so I will get lower. But I want number, numeric, I'm saying no, I don't want any numeric, so I am taking it as false. And I want upper, no, I don't want any upper, so I am also taking it as false. So this lower is true, this numeric is false, upper is false, and I don't want any special character, so special character false. And one last thing which is required is the length, so I want length of maybe six characters. So the output of this will be something like, let me give you an example, something like a b c d e f, a b c d e f, something like this. It will give some random string, I'm just writing it. So it's a random string which will be the lowercase characters, there will be no uppercase, there will be no numeric, and there will be no special character. And why? There is a reason why I'm using it, because I'm going to use this random string for my storage account. And as I told you in my last slides, that storage account in Azure should be unique. So with the help of this random string, I will add this random string here, and when I add this random string here, it will create a storage account with the random string, so it should be unique in the Azure cloud. So now I'm going to use this provider into my storage account. So let me remove this. So I just keep it like storage ACC, and then I will use the output of it. Now how to use the output, this is very important. This is the first time I'm introducing you concatenation in the existing. So I want to concatenate the output of resource random string of resource name random string here. So what I'm going to do, I will use dollar bracket, and in the bracket I will define random, this one, the package name, dot random string, dot, it should be value, it will give me the value. Let's go for the documentation once again. So it will length I have to define, these are the optional parameters, and then I will get an ID and the result. So it's not a value, it's a result which we require to add here. So it will be result. So this result will be 6 characters string of six character string of lower characters. There will be no numeric, no special character, and now it will get concatenated with my storage account name, and then my storage account will get created. Okay, so now you can see how this block look like. So in the Terraform we have defined this random provider, that we have to define that I want to use this HashiCorp/random provider, I want to use this version, and then what feature I want null feature, then I'm just adding it here. And now important thing, since we are using this new package here, new module here, so what we are going to do, that we have to run Terraform init. And now let me show you that when we run this Terraform init, it will try to, okay, sorry, we are not in the correct folder. Okay, so we have done another mistake. We should have this copied over to, not this one, we should have copied over to 05, because it's a 05 module. Let me copy everything here. and paste. I will correct 04 module later. And now I'm going here for cd 05, and now I will run Terraform init, and you will see, okay, spelling mistake, and you see here it is trying to download my Azure RM with this version as well as my random provider with this version. So it is trying to download all those providers. Now I will run Terraform validate just to validate that my code is correct. Okay, the features is unsupported block, so that means there is something wrong in here. So it's this features is an unsupported block. We don't require this block to be here. It's not part of it. That's all. Oh, sorry, I have to remove it from here in random. Save. Let me run my Terraform validate once again. Okay, success. So my configuration is valid now. Let me try Terraform plan. Here I will show you one important thing when I run hit plan. So this Terraform package, this random provider will give you a random string. But there's an important thing here. It will give you random string, but if you run the same code again and again, it will not give you change of the string. It knows that when you are running this Terraform this resource random string, it will generate the same string if you are using the same state file and the same resource. So it will not like whenever you create a storage account and you try to run again the same code and it will generate a new random string and it will again create a new storage account. No, it's not. It will create the same string again if it is going to run for the same storage account where this random provider ran earlier. So now you see here it is trying to run and we don't know what is the ID right now. We don't know what is the result right now because it will generate at the runtime. And what else it is going to create? It is going to create a storage account and some other resources as well. Resource group, storage account, and network, etc. So we are going to just deploy our code. Terraform apply. Okay, it's creating 4 resources. Yes. Here you can see it is giving us this random string HAJBOP, and now it will concatenate with our storage account suffix, which is st storage acc, and this will be added and then it will create the storage account with this name. So let it get complete first. 4 resources has been created. Let's go to portal.azure.com. Go to resource group. Let's see this one, and you see, so it has created HAJBOB string, and here you can see it has concatenated HAJBOP with my storage account name, and it has created the storage account. So this is how we can use the providers in our packages. So we are going to destroy everything now. Terraform destroy. So we have specified provider blocks, specify the required providers. We have added the random provider in our code, and also we have updated the storage account resource. And now the next thing which is very important in our Terraform is planning and dependencies. So whenever we are creating a Terraform plan, it will try to refresh, it will try to refresh our state file. So whatever we have provisioned earlier, it will try to refresh that state file with the code which we have written. That, for example, right now we are working on three resources mainly: storage account, vnet, and resource group. So it will, what it will go, it will try to do, it will see that whatever resources I'm creating in my code or deleting in my code, the same is written in the state file or not, and what are the difference, and it will return the difference to us. So it is going to tell us what is the resources going to be created and what is the resource going to be deleted or updated, and depend on that it will create a dependency graph. So in our code I showed you that, for example, let me take you to the code directly. So how it is going to create a dependency graph? It will create a dependency graph just like we are creating a resource group here, and then we are creating vnet and storage account, and you can see in the vnet and the storage account we are using this reference to my resource group's location and reference to my resource group name, and for both the in both the resources. And since we are referencing to this resource group, that means our these two resources are dependent on these two resources. That means these two resources cannot get created before our resource group is get created. But once our resource group got created, then these two resources get created parallelly. They are independent from each other. So let's go to the slide now. So it will create a dependency graph, and from the dependency graph is get to know what are the resources getting created, updated, or deleted based on your changes done in the Terraform file as comparison to the state file. And then it will see what resource can be created first and what resources can be created parallel, and it will start creating resources. So it will try to create as much parallel execution as it possible. But there is a problem here in the parallel execution. Sometimes it happened like, for example, you want to create a resource A first, and resource A is dependent on resource B, for example, and there is one more resource, not resource A, resource B is dependent on resource A, and there is resource C is also dependent on resource A. So now if we define this block of resource B and resource C, we will reference some variable from resource A that I want this value coming from resource A to here, and the some value properties coming from resource A to here, and then this resource C will be created and resource B will be created. Now what if we have one dependency on B for resource D? So resource D will be created when our resource B will be created. Now for example, resource B will be created when resource A will be created, and now we have D. So but what if your D requires dependency on C as well, that when it will create, when we want to create resource D, somehow it has dependency on C, and when it is having dependency on C, then this resource will get fail, that it will not get created because it has two dependency, one is on B and one is on C. It got created because we have defined some reference variable from B, that's totally fine, D created fine. But if this C is not there, C is not present in our infrastructure, then D is having some indirect dependency on C, and then D will get failed. And because D get failed, how we can resolve such kind of scenarios? For that we have syntax called depends. So if we have such kind of scenarios where one resource is dependent on other resource dependent on third one, but our Terraform is not able to recognize this dependency graph easily, then we have to use this depends, and with the help of this depends we can we can tell Terraform that this resource should not be created until unless its dependent resource are not getting created, its parents resource are not getting created. So for that, let me see if I'm able to describe you here in the code. So I'm trying to create a storage account. Now everything is fine because I'm taking reference from resource group. That's why automatically Terraform get to know that a storage account is dependent on resource group. But what if I want to tell Terraform in the code that it should be dependent on resource group? For that, we can write depends on, and here we can define those resources. So for example, I am saying it should be dependent on resource group. What if it's, and then I can add more resources like demo, vnet. So now if I tell like this and then try to create, yes, first let me destroy it, and then I will, if I will deploy my code, then you see first resource group will get created, our vnet will get created, and the last our storage account will get created. So right now it's running parallelly, everything is running parallelly, but let's complete this destruction and then we will try to redeploy our code and see. Okay, destroy completed. Let me clear my screen and I will check the validation of my code. It's valid. Terraform apply. Let's do the Terraform apply, and I'm making it big so that we can see everything here, what's happening. I'm stopping it in the middle because I haven't saved my file. So I have saved it now, and now I will try to deploy it again. Terraform apply. Okay, so it's telling me that these are resource, 4 resources are going to be added, 0 is changed, 0 is destroyed. I'm saying yes, I want to create. And now here you see, it's first it is creating random string. Now it is creating resource group and the vnet together parallelly, you see. But vnet will be created once resource group get created. And now since vnet creation is done, then it is trying to create the storage account. Storage account is still creating. So you can see here, first it has created the resource group, then it has created our vnet, and then it has created our storage account in the last, because I have defined the storage, I have defined depends on storage account, that it is dependent on our vnet as well as resource group. Now maybe I have a history, so let me go up and see the earlier apply, that how it looks like earlier apply. So it's run like this. So here you see random string is getting created, then at the same time we have this resource group getting created, and once resource group start creating, you see these two lines. This is important. You see these two lines, both vnet as well as storage account start getting created parallelly. This is important here, that vnet and storage account start getting parallelly, because these both resources are dependent on resource group. They are not dependent on each other, and that's why they parallelly start getting provisioned. And that's how Terraform has saved some time here. And in the last right now, which we have defined the depends on block, here you see first resource group get created, then our vnet get created, and then last our storage account start getting created here. Sorry, then last our storage account is getting created here. So this is how we will define the dependency graph. It's a basic which I have told you, but it's very useful, because when I personally tell you, it's very useful, because when we created 100 resources, it can be possible that Terraform cannot recognize all the dependencies by itself, and it will fail for dependencies, that it is trying to create resource A, but resource A is dependent on resource B, and resource B was not present at the time, so resource A was not able to create, it's failed. So for that we will use this depends on, we will use this depends on, and this depends on will tell Terraform that please do not create this resource until unless its dependencies are not ready, it's not provisioned. Okay, let's go to the next, deploy configuration. I showed you configuration deployment and the summary. So in this providers module, we have learned what are the providers are there in the Terraform. We discuss about one provider called random. We know how to use those providers. My recommendation to you, always use providers which are authenticated. Hopefully, like I showed you, the HashiCorp is creating those providers. If you are going for open source providers, please try to go deeper into some comments or somewhere you get to know the authentication of that provider, or the person who is writing that open source provider is used by multiple people, then only use those providers. Otherwise use always HashiCorp or some authenticated providers only. That's all from this course. We will move and discuss next course about functions and looping. Let's start our sixth module, which is functions and looping. This is very important module, little bit technical, but it will definitely help, and you will have to use it in your code whenever you are provisioning resources for big project or big organizations. So as you know, the name functions and looping, it will recreate your resources multiple times with the same configuration, with the same policies which you define. And functions are predefined predefined Terraform functions which you can use when you're defining some properties. So let's start with loops in the Terraform. So there are multiple kind of loops in the Terraform which you can go and documentation and see what are the loops present. There are two very famous loops, are one is the count loop, another one is the for each loop. So these for each and count loops you can use when you want to create multiple resources of the same kind. For example, you want to create so many storage account with the same configuration, you can use counts or for each to create multiple storage account. So in here, if I go to the syntax of count loop, you can see here in the syntax that I'm trying to create two storage account. I'm mentioning here two, and then I'm defining the name of those storage account on the basis of count index. And then remaining properties is like it will create in the same resource group, in the same location, with same access tier, account tier, and same replication type. If I want to define some more property here, we can define it, and the two storage account will create of the same kind of properties. The only change is storage account name, and that's true that we cannot create two storage account with the same name. So this is the count syntax. We will definitely see it in the demo. There is one more which is for each syntax. In the for each syntax, you can see here I'm trying to create resource group of I'm trying to create two resource group. One is a resource group, one is another resource group, the name of them, and another the property which I am trying to change is the location. One resource group I'm going to create at East US, and another resource group I'm going to create in the West Europe, West US 2. So when I'm trying to create these two resource group on different location, I just define these two properties, the key and the value. This is the key, and the left hand side is the key, and right hand side is the value. And I am iterating on this. First iteration will go to this one, the second iteration will go to this one, and it will create with the name. So first iteration, it will go for a resource group, so name will be, it will be a underscore group. And here in the first location it will be East US, and it will create a resource group with this name in this location. And the second iteration, my name of the resource group will be another, so it will be another group, and the location will be West US 2. So this is how we are going to use for each loop in our code. We are going to update our virtual network now, and let me see, we are going to update virtual network, we are going to update our storage account, and then in the function I will demo it together when we will do it with the function as well. Let me complete the theory first. So in the functions, we have multiple kind of functions in Azure, in Terraform, and those functions we can use in our code to do some to do help us in creating, managing our resources and namings. For example, we have function called lower, so it will, whatever string you will write, it will automatically make it as a lower string. So it will automatically convert the capital letters into the lower. We have functions like min and max. So for example, we have one function like min, where we can define 2, 4, 1. The output of the function will be 1. We have function like lower, we have function like upper, we have functions like join. So there are so many functions in Terraform which we can use to in our code and utilize them to create names, etc. And we will demo it. Definitely we will update our storage account with the lower functions in the demo quick after this, and then later on we will deploy. So let's move for the demo. I have already copied all these main output Terraform and variable file from fifth module to the sixth one, and now I am trying to use the functions first. Now, for example, if I have a requirement that I want to create a VNet with adding the location as well. So in this is our variable. Let me open it in the right hand side. So right hand side, I will close it. It's easy to understand then. And let me just little bit lower it. So now I want to create a my VNet name with this location. So what I'm going to do, I'm just adding it here. So in this one, I'm just adding dollar bracket and then var dot location. So it will be location. This and same if I want to do in the storage account, but let's check this one. In this one, my code will fail. When I will run this code, it will fail because in West Europe, we have this space here. So for example, if I want to create it, maybe in the plan, it will run fine, but let's see. Terraform validate. It will definitely validate because right now I haven't changed my directory. So cd out cd 06 and then run my Terraform validate. Missing required provider. So okay, I haven't initialized my code here, Terraform init, so that I will initialize my code. All the providers should be present here. Okay, let me clear my screen and then run Terraform validate. It is giving success result because my syntax is absolutely right. There's no problem in the syntax. Now if I run my Terraform plan, Terraform plan is also running very much fine. Now let's apply Terraform apply. Let's see what will happen if I want to create a VNet with space. Okay, so this is what expected, that creating updating virtual network name VNet demo West space Europe in our is fail, sending status 400, invalid resource name. Resource name VNet Europe is invalid. The name can use up to 80 character long and must begin with a word character. It must end with a word character or with underscore. The name may contain, these are the special characters which it contain. There is no mention of the space. So now we want to remove this space from my code. So what I'm going to do, I am going to use, these are the functions which we have here. So I'm going to use one of the functions. We have chom function, remove new line character. We have this join function which can join, produce a string by concatenating all of the elements of the specified list of the string with the specified separator. So for example, if I join hyphen with these three, then we will get the output as foo hyphen bar hyphen bars. So just like lower, which I was telling you, if I lower this hello, it will print in the lowercase hello. And same like we have this regex, replace we have, and the replace we will provide a string, and we will provide a substring, and then we will replace it with some other string. So this is what we are going to use. We will replace space with a null string. So let's use it. And how it works, we have this string 1 plus 2 plus 3. I am replacing my plus to the minus, and output will be 1 minus 2 minus 3. Let's go on the code here and let's replace it. So replace bracket. So this is my first string here, and now let me try to give it comma, make it big. And now here I want to replace space from empty string. This is what I'm going to do right now. So this is the replace which I'm going to do. And now what I try to do here, that I want to join underscore, or I want to join the location into my storage account. So let me try to make it as a join. And what I'm going to join here, I'm joining storage account. So I'm giving it as a random string, because storage account should not contain any special character, or maybe, but we don't have to go deeper into it. We are always using integers and the string. And I am joining this storage account name with my var dot location and bracket close. And var dot location contains space. So what I'm going to do here is I have to use replace again on this one, and we can use multiple function on each other, there is no problem. So replace this, and what I'm going to replace here is I'm replacing my space from null value. There's no string is here, so it's not null is different, and there is no string. So this is what I'm going to do. I'm going to create a VNet where I'm adding the location, and I'm going to create a storage account where I am trying to concatenate the location. I'm joining the location with my storage account and the random string, and since it is containing a space, I am removing space with the help of the replace function. Let me save it and try to Terraform validate. So it's saying some problem. So it's saying line number 14, storage account, replace join this. While calling join, var location is a string, var dot location is a string. Okay, so it is telling list of a string is required. So join is required a list of a string. So that means we have to define this list of a string, not the simple characters. So we are defining simple string, it should be a list of a string. So I'm just doing this. So it is a list of a string where I have the first one in the join. The first one is the character which is going to be joined each string. So it's empty space, so there is no space, and then I am giving this first string, and then I'm giving this second string, and then it will join with this empty, and then in the location we have a space. This replace will remove this space with the empty string again. Okay, so let me try to run the code. Terraform validate. Okay, I haven't saved it, so I have to run it again. I have saved it now. Okay, configuration is valid. Let's try to apply now. So we are going to create resource group. We are going to create a VNet with the name of VNet demo, then West Europe, because we have this West Europe. And then we are going to create a storage account, which is name like storage account. And then we have some, we have West Europe without space. We have, we already seeing some error here. So name can only consist of the lowercase letter and the numbers, and must be between 3 to 24 characters. So let's see how many characters are here. So it will be like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. 100% is more than 24. So we cannot create a storage. We learned today that we cannot create a storage account which is 24 characters, more than 24 characters long. So now we have to make small change here. What we are going to do, we are not going to add location here. What we are going to add here now is just a random string like AAA, 3 characters. So now in these 3 characters we have and we will remove some characters from here so that it will create that. So we have this 1 2 3 4 5 6, then 6 random string, so it will be 12, and then 3 here, so it will be 15. I hope it should create this one. Terraform validate. Now Terraform apply. Okay, now you can see here it is going to create 2 resources, 0 to destroy, 0 to change. Let's create 2 resources. Yes, because remaining resources already created. It failed only for storage account, that's why it is creating that. But remaining resources are already created, so we don't have to worry about that. And we have defined the depends on, and that's why you can see that first VNet is getting created and then storage account is getting created. If I have removed this depends on here and from my code, if I remove it, then the storage account and VNets will create parallelly. So I can see the storage account has been created and VNet has been created. Let's verify from Azure portal. Okay, we are here. Let me refresh. You can see I have defined this AA string to be added here. Now it is created. And in the VNet, I have added West Europe location and concatenate the string location with the VNet, and that is also created. And we have using functions to add these AAA with the starting point, a starting string, and we have used replace to remove the space from the West Europe. So we have used these 2 functions, and by the way, we have so many other functions which you can use for yourself. Okay, so now moving on, we are going to demo for count as well. So for example, now we want to use count. So what I'm going to do here, I'm going to create multiple storage account, like 3 storage account I'm going to create with the help of my count variable. So its count variable is helping me in the looping on my resource to create multiple resources. And now how it is going to be done, what I'm going to do here, I'm just concatenating this count value in here. So just creating comma, and let's use this count dot index, and it will give me the number. So it's a 1 2 3, and it will create the storage account exactly with that. So let me try to run my Terraform Validate quickly so that we don't have any syntax error. No, there is no syntax error. Let me try to deploy it. Terraform apply. Now here you see it is going to destroy one resource and going to create three resource. It is destroy one resource, that storage account which is already created. It is going to destroy it because our Terraform is maintaining that storage account, and now that storage account is not describing here. We haven't described, we are describing three new. So that means we are telling our Terraform is telling to the state that please remove this already existing storage account and create these three new storage account. So let me try to deploy it quickly. Okay, so we are able to create three storage accounts and we have destroyed one. Let's verify it. We are going here. Let me refresh. So now you can see there are only two. There should be one more. Yes, so now we have. Now what's going on with the Azure? Okay, so now you can see here we have three storage account created and we have added only the count index 0, 1, 2 here, and now we can iterate three times with the same property of the storage account and getting three resources over here. So now you know how to create multiple resources using count. And let me know if you want for each also, then I will demo it in the separate video because it's works similar like this. Okay, let's go to the presentation again and let's see what else is remaining. So we have done this loops, we have done count syntax, for each syntax, updated virtual network, updated storage account. We have gone through functions like lower, join, replace, etc. We demoed it, updated storage account with a lower function. We haven't done it, but it's very simple, you know that. And we just use the lower function in the name and that's all. Then deploy resources and the summary, and this is all we have completed in this module, all the functions and looping. And moving on to the next module, which is TF modules, Terraform modules. This is most important topic and this is, you should not miss it, and go through with me with each line. Don't miss anything here because it is important. Why I'm saying, because when you are working in a team, modules are very helpful, because if we are working with a team, all the team members should use the same module for creating the same resources, and that's why modules are very important. So we will start module in 1 minute. Let's start this last module of our getting started course for Terraform, Terraform modules. It's very important, as I explained you earlier, that it is when multiple team members are working together and they want to create resources of same configuration, they can use modules and they can use this module multiple time, create multiple resources of the same kind. So Terraform modules, what is Terraform modules? Modules are containers for multiple resources that are used together. A module consists of a collection of Terraform file, that is .tf or terraform.json files, and they are kept in a separate directory. Modules are the main way to package and use resources configuration with Terraform. Now, how the module structure look like? So let's discuss this module structure. Over here you can see all the Terraform projects, they have always one root module. So for example, we have seen in our file structure, we have seen main.tf files or variable.tf files. So we have that root module, that is called a root module where we are calling other dependent child module. So here, this is, till now we are working only on root module, we haven't used any different modules till now. But now we are going to create a child module, and in the child module we will define some resources and we will use those modules over here and give some extra parameters or extra variables and use it. And these child module can nest to another child module as well. There's no problem in that. So this is the structure of the module. The main module is the root module where we are using, you are writing our code, we are running our Terraform plan, apply, init, everything. And then we have this child module which contains our Terraform files like .tf, .tf.json file in a separate directory, and we can use them. So child and these child module are can use nested child module as well. Now, how the syntax look like when we are using these modules? So in our root module, we will define it like module, the name of the module, and where our all files related to the module are present. We have to keep all the files, all the .tf and .tf.json file in the same directory for the same module. So this is, we have to define it, and then we have to define some other properties as well, and once we run it, it will create the resource which is defined in our module. Moving on, now we have a demo for, as we know, we are working on virtual network and storage account. We are going to create module for virtual network, we are going to create module for storage account, and then update the module, main module, which is our root module, and then we will deploy it. Let's see how we are going to work on it. So I already copied my code here. You can see my code is already here. And if I go to the documentation of it, so in the documentation, you can see these modules. These are defined by multiple like Terraform, AWS modules, VPC. There are so many modules is defined. More than 1000 modules are defined here. So you can see it is 14,414 modules are defined, and we can use this module easily, or you can create your own module according to your requirement of your project and then use those modules by yourself. So what I'm going to do here is I am going to use my own module to create VNet and to create a storage account, and then use that module in the provisioning. So I am creating one folder here and call it as module, and in the module I am going to create one more separate folder for VNet, and there will be one separate folder for storage. So we have these two. Okay, I have done one small mistake. This storage should be inside. I delete this one, and I will go here and create another storage directory, and I will keep my files here. So in the VNet, what I'm going to do, let's create first file, which is main.tf. You can name it anything, because whenever you are compiling it, it will automatically compile all the data which you written inside tf file. And I'm going to write here one more file, which is variable.tf, just to separate out and looks good. And in the storage also I'm doing the same. I'm just creating these two files here, empty files, and later on we can write down our code. So in the main, what I'm going to do in the VNet, let me open variable in the right hand side. It's easy to understand. I don't want to build a new thing here. I just copy my code, VNet code here, and paste it over here in my module. So let me close this, and now over here you can see I have name needs to be defined. So let me replace everything, remove it, and I will define a small variable, okay, and variable name is VNet name, and you know how to define it. It's a type of a string, and the name we can define it like default value we can give is VNet demo 1, VNet demo 1, just new thing. And here we can use it as var dot vnet name. Now you can see we cannot use this right now because this root is this resource group is defined in the root module. So in the root module we cannot go like this. I showed you in my screen in my presentation here. So we cannot go other way around. We have to go from root module to the child module, then the second child module. We cannot go like from second child module to the first child module and first child module to the root module. We cannot go in this direction. So for that we have to define the location. So I will define the location here in the variable quickly, location, and let's define it as West Europe, our default West Europe, and let's give it as location. And the resource group name, we also require resource group name. So same thing once again, one more variable here, and here we can write it like rg name, and rg name is default hyphen rg, same like earlier, and then we can use this. Okay, so we are done. And now in the variable we have defined these, and in the main we have defined these properties. Now what about the storage account? Let's go to the root module. This is our root module. Let's cut down this as well from here and go to the storage account and try to create. So in here what we are going to do, we are going to replace the name, and I'm removing, I don't want to create multiple count here. Let's save it, close it, let me close this also, and we are here. So let me open storage account variables. It's nothing. So now what is the name? I will copy the name once again quickly. Variable name is stz name, and type is string. Okay, and here I'm going to give a default value is stag account random string. And what else is required? Seems like resource group location. Let's copy from here so that we will not waste our time. So going to this, I'm pasting here. So now we have defined our module for storage account, where we have defined this name, variable storage account name, then resource group, variable resource group name, and location will be the location variable. Okay, and we have defined these three variables here. So this is present in the storage directory, and in the vnet directory we have this main, where we have defined the vnet definition, that what is going to be created, and the variable, that what are the variables are required. So let's close these two. And now the important part, now we have to define in our main, we don't require this now. Now what is required here is in the variable section. I will open it this in the right side, that we want to use to create vnet. So what we have to define, we have to define the module now. So module, the name of the module is, I am creating as vnet demo. So module name is vnet demo I am creating, and here I have to define the source. What is the source of this? So the source is, I have to give the directory name. So I have to go to module and the vnet. This is the directory name where my module files are present, like tf. Right now we are using only tf files. And then what are the parameters it is required? So if I see here, it requires vnet name. So we have to give the vnet name if we want, or if we don't want, we it's not required to give any vnet name. So let's give a vnet name here. So I want vnet name 1 2 will be created, and then what else? It's required rg name. So I will give rg name the same which is getting created here, but I will use the dependency graph so that it will not fail. So Azure RM resource group dot name, and then I need the location. Then for location we can use the dependency graph for resource group dot location. That's not a problem. And what else is required? Required nothing else, so we are good. So we have provided all the 4 parameters. 1 is the source, 3 are the parameters. So let's go to vnet just to recheck. We required name, location, resource group, and address space we are already providing here, so we don't have to provide it over there. So let's save it, and we are going to create another module name stg demo. This is the module name, and the source will be dot hyphen storage. So this is the source where our all the tf files are present, and here we have to define the name of our storage account. So we have to define stg name. Stg name will be somewhere like stag something random string. Then we have to define location of it. So location I am taking Azure RM resource group dot location. Then we have to define resource group name, rg name, and I'm taking Azure RM resource group dot name. And what else is required? Let's see, just to verify. We require resource group, location, tier, and replication type we already hard coded here, so we don't have to define it. So whatever properties you don't want to define over here in the root module, you can define it hard code here, so that each time the resource which get created, it will have this property intact with it. Okay, so we have these 2 modules, storage, vnet. We have defined those modules over here inside the module directory, and we are using them in our root module. Okay, so let's try to go inside 07 folder and then try to validate our code. Terraform validate, and I guess it will fail. Validate. Yes, it's failed because we have defined these 2 modules, but we haven't loaded them till now. So what we are going to do first is Terraform init. So this Terraform init, you see, this is downloading all the HashiCorp module like random, Azure RM, and etc. And also not only those, it is trying to load this stg demo and vnet demo module as well, and it is mentioning where the module files are present inside module storage, inside module vnet. Okay, so now if I clear my screen and try to run my Terraform validate, now the configuration is valid and we get the success result. Let's try to deploy it. So plan, okay, so here it is saying we are going to create 3 resources. So obviously one is the resource group, another one is the vnet, another one is the storage account. Let's try to apply it. The resource ID with this default RG already exists. To manage via Terraform, this row needs to be imported into the state. So we have this resource ID default RG has already been created under our module 6. And still, if you see here in this module 6, we have this state file, and in this state file we already have this resource group with the name of default RG. So that means this is very important actually. This error by mistake it's coming here, but it's very important. It's saying that if your resource is not managed by with your current TF state, with your current Terraform files, then it will not create that resource, and for that you need to import that resource. I will create a separate video on it so that you understand in the detail how to import files and how to import files when we have these modules. I will create a separate video for it because it's a little bit deep knowledge required, and we are creating this video only for getting started for beginners, so it will be little bit higher side for those. So that's why I am leaving it right now. I'm just going to update my resource group name from here. I am just creating default rg1, and now I will try to deploy it. Okay, so we can see here our apply is completed and we are able to create 3 resources. Let's verify going to Azure portal. So this is the old one which we already created last time, and now if I go to resource group, refresh it, we have this default rg1, and we have this 2 resource which is vnet12 and storage count got created here. So now now we have completed how to use modules in our code. We have to have separate module directory where we keep all the files related to that module, and we can use those modules into our main, or we can say our root module where we are running our Terraform plan, Terraform apply. And now if I go back to my demo, let's see what else is remaining. We discussed structure, we discussed syntax and scoping, we updated virtual network, storage account, we updated our main module, we deployed our resources, and the summary of this module, that now we get to know how we can use modules into our code. And now it's very easy. If we want to use the same module, we just have to create a similar kind of module once again, and then we just have to write one more, just this name or something like that, and we just have to update these properties, and automatically our storage account with the same property will be created multiple times. We just have to create one module here, and then we can create the same resource with the same properties with different name multiple times. So it's very useful for creating multiple resource, and multiple team members can also use the same modules while they creating their resources. So yeah, this is completed. So okay, so this is the end of our course, and we have completed our getting started topics. So if you have with me on the whole course, then that means you are able to write your Terraform basics, you understand the fundamentals of the Terraform, and you can manage your infrastructure using Terraform. This is a getting started course, it's a beginner's course. Let me know you like it or not, and also let me know if you want some topics to be covered, so I will cover them in the separate individual videos. Hit like and subscribe if you like my hard work on this course to be created, and if you have any suggestion, don't hesitate to mention in the comment box. Thank you so much for watching.